an experiment which is very familiar to you, that there is a candle over here. I take another candle, we pour some water, almost equal amount of water I have poured here. I am putting this glass on the top of it. What will happen? Some water will get up. These two glasses is of same size, and I have put a mark so that we know how much water will raise. That if you put it on the candle, then what will happen? It will consume the oxygen and then some amount of water will raise. But there are two candles and these two have same amount of air because they have the same volume. So if I place it on the water, same amount of water will rise. It has 10 cc of oxygen, then it will also have 10 cc of oxygen. We have almost same type of two candles, so I put it here. Let us see what happens. It is burning. Now you see some water has come up. It is also burning. You see, it looks like that they raise to the same height. The difference is not there. If there are three candles, then you would have seen that it has raised up to this. Just to show that under different condition, say I take out this, then I suddenly put it, then I wait for some time, then I put it, then I just immediately put it. This way vary the condition and see what happens, and you will see different things are happening. Let me explain the reason why it happens. Because when you are putting here, the air is hot around there. So what happens, as soon as you put it there, then what happened? Some amount of hot air goes out. How do you know air goes out? Unless you do an experiment, you cannot tell that some water goes out. Let me do another experiment. You see what happens when I put this bottle, what is happening? Why the bubbles are coming? Because the air becomes hot, it has a small orifice, so the hot air is coming out. So when the glass is put on it, what happens? The lots of hot gases goes out. It is not the oxygen. Then you will question, how do I know it is not oxygen? Now I have another experiment. This is a manometer connected by a side tube at the bottom. Now you have seen both the bottles were empty. Now this is a very important observation. Practically no water has come. Till the bottom of the bottle, this bottle is visible. Why? This is closed. When it is filled up with water, what will happen? The water will start coming here. This tube is filled up with water. In this bottle, I am showing that only few drops of water has come here, but this is completely empty and this is also filled up with this colored liquid. Now why it has not at least rise some little bit? Why? Because initially when I am pouring the water, air goes out. But as soon as it enters this tube, the small side tube, then what happens? It closes the mouth. So this air is trapped. So as soon as the air is trapped, what happens? The pressure of this gas increases because it tries to compress the volume. So that pressure can stand it. That means the pressure of this liquid is only can put half cc contraction of air of the same volume. This is one important thing. Because air can give a large amount of pressure by little bit of compression. This is an experiment for that. Now there is another tube. See the construction. Here I have put a side tube and I am going to fix it here. Now this is open to air, so I open this. Now the liquid will come here. Liquid is coming. let it be equal. Now they are equal as it is expected, because this is open to air, this is open to air, so this bottles now act as a manometer. Now if I burn this candle and put this bottle on it, then as this theory says that the air will expand and so it will press it down. Meanwhile, it will absorb the oxygen. So this volume plus this volume is the total volume of air which has oxygen. So if it is oxygen absorbs this 1/5 of the oxygen absorbs, then probably it will come back to this side, isn't it? Because of the dearth of oxygen. Now it's a very carefully you have to do, very quickly I have to do it. See, it is going down. It is still going down. Now it is rising because the candle has gone out. Now it has came back to the almost same level. Practically there is a little bit of contraction, there is no change in volume. 1/5 means it should come over here. Why? Because we forget that the carbon dioxide dissolves less than 1%, about 0.5%. So carbon plus oxygen is carbon dioxide, carbon is solid, oxygen is gas, so O2 and CO2 they are of equal volume, so the oxygen is replaced by carbon dioxide. This is nothing to do with oxygen, because oxygen is replaced by carbon dioxide. Then why this little bit of contraction? Because the candle is a combination of hydrocarbon, that is it is CnHn plus 2 plus O2, that gives you CO2 plus H2. This is very important in the sense, and how I have done this experiment, let me do the critical explanation of this experiment. I have taken a case like this. There is a plasticine. You know what is plasticine? So I put a plasticine so that this candle remain erect. If you take a long candle, then that will produce a flame which will distort this part. If you put the candle on the table, then also you can do the experiment with little bit of flour, you can put it there. But what will happen when you putting, if you hit the candle, it will fall here and it will burn it. This is number 2. Number 3, the ordinary bottle you cannot use. Why you cannot use this? Because with a small heat it will dissipate. When the pressure will be high and hot air will be there, it will dissipate. So that is why I have taken an Appy bottle.